Am I live already? That's strange. Anyway, 3 more minutes and we'll start. A bit strange. Can you on YouTube see me? Wait, Aline, did you just answer me? So, you're both in. Why are you both Zoom and YouTube? You know better. Okay. So, white or dark? The mood I have today. Okay. The white. The white. 9 participants. Share the screen. Bigger here. That's very weird in YouTube. One more minute, then we start. Just want to bring in the screen, the community. We never spoke for a while already, huh? Tried, trust me, I tried. Hard. Okay, today this, and I have another draft coming up. A draft, I don't know where do I see it, but I have I'm planning one more event. 11 people. We're gonna start already. Okay, so refactoring Python like a Zen Master. Now, yeah, Peter, yay, good. Let's have some fun with Python. Right, so we're gonna start with the partial implementation of the Yatzi code. Yeah, first of all, welcome back to my humble home from which I broadcast to the community everywhere. This today about Python refactoring clean code. We're going to spend 1 hour in Python, draw some conclusions that we can take in any other language, and normally any Python developer will be able to follow what's going to happen. So we're going to work with clean code, we're going to work with comprehensions, we're going to do refactoring using PyCharm. Why not? We're going to design some test cases, anything that will be used against you. All right. So want to skip having click to allow? Yes. Okay, thank you. Good. There were some requirements over here that if you never saw this program before, you might want to keep close to you. I'm going to drop them in the chat in Zoom. For those of you on YouTube, be aware that there is a Zoom meeting going on in which there is the most interaction happening. If you want to join the Zoom, you can just go to this page, quickly join the community completely free, and then be in the Zoom meeting where the fun is going to happen. All right. Oh, no worries. So there is some code in front of us that we're going to walk through. And the good part is that unlike real life, there are tests. Many of them green, but some red. Just enough to get us started, right? So this is a problem. Record to the cloud. It's recorded on YouTube. Why are we recording this anyway? Anyway, it's on YouTube and it's going to remain recorded on YouTube. Good. So we have the requirements over here. We have a test targeting each function that I'm going to keep running and working our way by practicing some Python along the way. So first, we're going to dive in and we're going to draw conclusions as we progress through the code. I think we're good to go. Let's do it. So in this game, we are given 6 dice. Right, we are rolling dice, and then once you have the dice on the table, you are able to choose from one of several strategies of scoring those dice. But the thing is that once you score one of the strategies, you can never use again the same strategy for further rounds. So technically, you can imagine this game is, I don't know, going like 12 rounds, and in each round, you throw your dice, and then it's a game of strategy. You have to choose which scoring technique to use that you believe is going to get you the largest score by the end of the game. So, for example, if you have on the table 1, 1, 2, 4, 4, 5 dice, if you choose to play the ones card, imagine some cards that you play, then you're gonna sum up all the times one occurs and sum up the ones in this. So 1, 1, 2, 4, 4, which will give you a. Am I looking at the right one? Yeah, this talks about the fours. But if I look at the ones, we're gonna score 0 because there is no 1 in that series, right? So maybe if it's 1, 1, 3, 4, 5, that's gonna score 2. So the idea behind the scene is that you need to choose the strategies, that's the game, but we're not gonna implement actually the game playing, we're gonna just implement the scoring in this game. The actual probabilities and strategies and machine learning, and that's another discussion for another day. But for now, I just want to, look at this tests, and then these tests should remain green. 1, 2, 3, just to check the understanding. There is one time appearing here, so that's why the sum is 1. 1, 2, 1. This leads to 2, and so on and so on and so on. So, well, it's interesting. So if the first die is 1, then something. If it's the second die is 1, then add again, and so on and so on. Of course, we can do much better than this. We could put these into an array. Let's try. And use collection operators. Right? Let's try. So first of all, I'm going to say dice equal. I'm going to put D1. Exactly. Thank you, Copilot. And then I want to sum those elements which are equal to 1. Let's do it the old school style. 4. 4. And I'm going to say, I should not be using AI, should I? Anyway, we're going to say die in dice. If die equals 1, then sum plus equal to 1. Why do I have some hard feelings about using AI? Because as we know, but many of you might want to see this, AI can hallucinate us in some creepy, very creepy ways. This is one of the sources of the most dark bugs today. And I want to show you the latest discovery we had. We were a group of very experienced developers, and we were looking at this. I practice this approach. It's called, I call it prompt-driven. You comment some code, and then you let AI continue the phrase. So the code looked like this. If user contact is present, then get the contact and add it to the CC. This was the original code. And several days ago, Copilot suggested to replace this with this piece of shit code. Do you notice the problem? I mean, we are still struggling, I believe. So there is contact over here, there is email over here. The guy was adding, the dog was adding the wrong thing. The correct one is this. So you see, it was hallucinating us in a very, very well-looking form. So be very careful. We were shocked by this syntax over here. What the hell is going on? But in the end, the AI was completely misunderstanding the code. And it took us many minutes to find the bug. What the heck is going on? It looks so good when AI hallucinates you. That's why I'm a bit afraid of it. If die equals 1, then sum. That's the first way to do it. Amy said that never happened, exactly. Sum equal, that's the first way to do it, and this test should still be green, all good. But we can do better. Of course, in Python, it's a pity not to use comprehensions for this purpose. So, without AI, we're going to type it. I'm going to say, instead of returning a sum that I put to 0 and then I add going through a list, why not doing like a sum of a collection? But how do I select the collection that I want to sum? Well, here goes nothing. I'm going to say array, technically comprehension. Let's start backwards. Maybe it's better to drive from here to the comprehension. You see, for die in dice, I'm just going to put if after that in the same line. and this. And basically, I'm getting over here a comprehension. Every die for the die in dice, if die equal 1. So I'm selecting the items that are equal to 1. Okay, I'm just converting. The test is still green. I'm a bit afraid now about me going wrong with the test, so let me do a bit of a mistake here. Let's put some zeros just to be sure that the tests fail. Yes, the tests appear to fail for bugs. All right. So that's more like it. In one shot, I compute it. This is called list comprehension, and that's the Pythonic way to write your code, right? The more it's compact and expressive in the same time. And by the way, this reads in better than Kotlin, Scala, Java, PHP. This is absolutely fantastic in Python. It's a pity not to use. Sum for every die for die in dice, if die is equal to 1. Good. Let's go for the next case. Scrolling down, we find the next case. Def chance. The player scores the sum of all dice no matter what they read. Oh, that should be easy. But then I realized that I am now crossing in. I will share, by the way, at the end the original code that you want if you want to practice with your team. I really recommend you do this. No matter your experience level, you should be able to follow. You see here, I'm starting to add from a dice array living on an instance in which I am currently in. So now I'm playing an object over here. So in order to call the chance method, someone has to instantiate a class, you can see here. And then on the instance, call chance. That's very convenient, actually, to have those dice stored in an object. Why? Because I'm going to keep using those dice to test various strategies, all right? Exactly. So then here, what I can do as a small refactoring forwards is to say, okay, I just need to add all the dice on the self. So when it's sum of the self.dice. That should do the very same thing. Run. What should I be looking for is the chance. Let's find the chance from here. Test chance is still green. Good. I'm gonna keep. Let's plug them. Maybe if I run this, can I just put this? I believe I'm gonna keep manipulating this over and over. Can I just put it in here? Yeah, thank you. Excellent. Perfect. Nice. Good. So chance is and should remain on the same place. Chance is here. Good. Now I can do, of course, in line of the variable. I don't need the variable to just return it. Of course. This should, of course, go again green. I insist on this. We are looking right now at a refactoring /TDD kata in which the tests are pre-written. It's the perfect place to play out different ideas. It's the perfect playing ground for every one of you, right? I'm working on my own. Ooh. Nice, but still, Copilot in Python is king. Good luck with that, Mihai. Count 0, what the heck is this? I multiply, basically I create an array of that many elements. Okay. And then, why do I do this? What am I looking for? If all dice have the same number, the player scores 50 points. Ooh, what is this? This is too hard for now. Let's skip it. Do later, right? Do it on Monday. I'm kidding. I'm going to iterate back on this. For now, let's just ignore it for now. Twos. Hey, wait a second. Twos. I think I did once. But this is in the method. The other thing is outside of the method of the class. Why is that? Let's bring one into to have more consistency in the approach. Well, by the way, anything I will show you today, please take it with a grain of salt. The easiest transition is to have here a static method. Because if you have existing code looking in some way, you don't want to turn it upside down just because you attended this meeting, right? So this would be Yatzi dot. By the way, is it with Y? We have a problem with typo over there. Okay, then this. Like this, and I'm calling once, but then I realized, wait a second, this was a different approach than I saw in chance. In chance, the parameters were not passed to the method. In chance, the parameter were passed through the constructor over here. So let's align the solutions to that. I'm going to make this, first of all, run it again to make sure the ones are still green, correct? And then I'm going to turn it into an instance method, effectively giving up on taking these parameters, passing self as my own object, and then getting the actual dice from self. Much better. I have to align the tests now, though, and I'm going to use my favorite refactoring and my favorite editing in IntelliJ, which is to have multi-cursors. By the way, I should enable the presentation assistant so that you can see what keys I press. Now, guys, I'm not trying to sell you IntelliJ, but I'm trying to sell you PyCharm. Visual Code does not have this feature, but some others it doesn't. So you see what I can do? I can do Yatzi instantiate dot once. Not perfect, because here it went backwards. 1 equal. Align it a bit, and there you go. Now I'm instantiating, and it should again be green. Perfect. So I have ones, I have twos. Twos is static method. Why? I've done it already. Oh, I know. Can I copy paste, mom? Let's try. Copy. Paste. Yeah. And I'll put 2 over here. Only thing I need to take care is to convert this into a instance method as well. The 2's are then have to be refactored over here with the same technique. I'm gonna copy this. Control G, parentheses. Oops, almost done. 2's. Yay. Good. It's called multi-cursor, by the way. All right. So I have 1's and 2's. 3's. Oh, somebody really on this one. Somebody stop me.
Somebody stop me.
Yeah, 3. Do I see 4? Yes, I see 4. I don't give a heck what they did before. This is what I want to do. I see 5. Thank you. Oh my God. I'll be so productive today. Yeah, baby. 6. Done. 1, 2, 3, 4, 5, 6. Good. Okay. The best developer on the team is the one that deletes most code. Good. So some of these dice, I don't think I did anything wrong here. Now I'm warmed up a bit, so I may go to the next one. Let's see, score pair. What is this? The player scores the sum of the 2 highest matching dice. Ooh. For example, when placed on pair, this scores 0. Why? Because there is no pair. No pair. Guys, I'm trying to suggest that if I would care for my tests, I'm gonna create for each of these separate tests, more fine-grained, explaining what's the reason behind. So returns 0 because there is no pair. I might as well go to the actual test, where is pairs, 1 pair, and create different tests for this. Let's give it one shot, just to prove the idea. Test, and then pair, 1 pair, returns 0 for no duplicate, no pair. Maybe you could say it's obvious, Victor. Okay, but that you can do if you want to be super clear what you're doing. So this should be 0. General bit of verbosity does not kill anyone. It's explaining for score pair. Good. Now, how do I implement this? I need to score to find the pairs. How do I do that? Well, I smell a bit of a O(n) squared. I could do like nested loops, but that's too naive, but could get me going in some direction. So, but still, how would I see which is the biggest? Let's try this once. 4. I want to get I don't know, maybe some D for value of the dice from in 5 to 1. How do I do this? Basically, the biggest value is, how do I do this really? So in no. I could do this to go backwards, but it doesn't really work that well, does it? Let's try to prompt engineer this. Go down from 6 to 1, go through the array and see and count how many occurrences there are. It looks like hell. Count how many occurrences you found. You're fine. I think that should, let's enable a bit AI. Let's try. So maybe a 4. Something like this. in the range between 6 and 0 decreasing, if self dice count of I more than 2, then I times 2. Will that work? Going from high to low, score pair. If you see me doing something wrong, tell me. By the way, this is why do we call it score pair? It's inconsistent. Let's call it one pair. One pair, two pairs. Okay. So I'm going from the highest to the lowest and seeing if there's at least 2 occurrences. If there are, I'm going to return that value multiplied by 2 because there are 2 dice. It could be 3 occurrences. It could still work. If you find a case that would not, let's see, that should match 3, 3. Okay, 6. This 4 occurrences should match 3 and return 3 times 2, 6. Good. I think that works. Okay, I survived this one. Let's see the next one. 2 pairs. Oh, damn. If I find 2 pairs in the game, then you sum them together. Now, since you have 5 dice, you cannot have 3 pairs. So 2 pairs. 3, 1, 1. And then here you just have 1 pair, and because you don't have the second, you score 0. So you see, if I would implement the strategy behind the game, of actually playing the game, if I would see 2 pairs on the dice on the table, I'm going to play this card immediately because it's quite if I play this card on, if I don't have 2 pairs, it's pretty hard to have 2 pairs. So this one has only 1 pair. Interesting. So it doesn't count like correct. You see, we now have to basically see how many occurrences of each digit we have. Now, to understand the reasoning behind, I have to take you to 5th grade, my daughter, who is studying at computer programming, is studying the frequency array. A frequency array, this is a concept in programming which is very useful here, is an array that has, for example, if I play on this array, the frequency would be an array in which on the position, how to phrase it to be easy, let's make it a dictionary for now. 1 appears 2 times, 2 appears 1 time, and 3 appears 2 times. Yeah. I'm going to count how many times each value. Yeah, a dictionary, exactly, Alex. I was hesitating. An array, nah, let's make a dictionary. So we're going to count how many occurrences of each value we find. Okay. Let's see if I can do this. First, old school. I'm going to go through the dice. Let's stop the eye. 4. By the way, recently I had to develop a lot of code. I'm doing a training today in Kafka streams. I had to write a lot of code, and AI at some point gave me a headache. Counter. So you say that I could do, let's say, don't know that. I could say self.dice dot counter. Nah, I'm gonna do gold style. Thank you, Alex. I'm gonna copy paste straight from your message in my code. Crowdsourcing here. So if, okay, mind the tabs. All right. If I in D, perfect. If I have that key, let's see if this works. Oh my God. And then what? I build the dictionary of frequencies, and then I have to see that I have 2 entries that have a value at least equal to 2. This would qualify. Right? Here, this one is going to result in something like, let's use, correct? So AI is best used with small dose, right? And then here, let's see, can I just iterate through? I need to iterate for key and value in dice. Okay. And then if, then what? And I have to see 2 of them to have. That's a bit annoying. How do I do this? I know, let's start old school. Count number of pairs equals 0. Oh la la, that old school. If value greater or equal to 2, then n pairs, oh my God, equals 1. Plus. Plus, Victor, bad habits. And that should be like this. Now, after I finish all this, I have to, oh my God, if, damn, n pairs. If I did not find 2 pairs different than 2, then return 0. Otherwise, habit. Otherwise, unnecessary parentheses. Otherwise, I will have to go again through them and sum up those that are like, oh my God, let's do it, let's do it. This is Sparta. I'm going to go again and I'm going to add them up. I could have done this in one go. I could have done this in one go. Let's do it here, like sum or square plus equal 2, just 2, because 2 times die key, I think. Am I true? Let's see. And I'm going to start with a score equals to 0, and I'm going to get, God help us all. Run. I'm afraid. 2 pair. Where are you? 2 pair, 2 pair, 2 pair. 2 pair. Apparently I missed one. Which one? Which one did I miss? Again, I should probably be printing something out at this point. Let's see. Maybe I need to print the what? The D. I should run just this. And it prints what? It's over here. At the bottom. All right. What did I do wrong? Dice. I print the wrong thing. D. Oh, the dice is not defined. Oh my God. Self. Okay. Self. It's a selfish language. Self. Run. Okay. D is not defined. What did I do wrong? D. Oh. Dict. Thank you. Good. Okay. Dict. And I'm not sure I should go through this or dict here. Dict, I think. Failed. Trace back. D again. D. D is back. Guess who's back? Back again. Shady's back. Tell a friend. Not unpack non-iterable int object. Did I write an int here? Help. Dict.items. Here you mean. Is it items? Are you sure? For E in self.dice, so basically I am iterating through the keys, I think. 2200, what the heck? Here, 91. The problem is here. This is dict.items. This is how a Java developer writes Python, huh? V, not again. Not again. E has values 3 2 times, but I need to understand what test am I running. So 3 3 5 4 5. 3 appears 2 times. God damn it, it's correct. 5 appears 2 times. Yeah, I'm good. I am good. I am on the right track. What else? Here, dict.items. Run. Ladies and gentlemen, do you see this? Who let the dogs out? Who let the dogs out? Who let the dogs out? It's been a long day, so I can relax a bit. Now, this is the first draft. This is the shit. This is...
Brother, what's that?
This is not Pythonic code, for sure. This isn't the novice junior code. With notice how well did I avoid this breakpointing by any means? Printing, avoid breakpoints. But we can do this much more elegant. Let's give it a shot. Dict equals. So what am I doing over here? I am plus equal and what if I iterate through the values from 1 to 6, and I just count instead of going through the dice themselves? Can I say here something like, what did I do before? Range from 1 to 6, please? That, I mean, I want to do this in a different way. This dictionary over here, I want to do it in a different way. And I believe I can. Let's see. dict again equals array, empty array, and then for, let's suppose I'm looking for a die for a certain value. For value in range from 1 to 6, then I want to count how many times this certain element appears in my, I don't want to do this plus equal or equal. This is just ugly. So I'm going to say directly dict of the value equals the number of times that in the self.dice count, I have a count, appears the value element. Would that work? I was looking for 1 pair. No, 2 pair. I broke something. And there was a very good placed, very wisely placed dict here. I need to look at it. And we have a problem because trace back should run just the one I'm concerned of. It's called 1 pair, 2 pair. Wrong one. Wrong button. Here. Launching unit test, and then we have this failure. It returned the wrong thing. Why? Dice dot count of the value. Help. Use set. What do you mean set? Dict dot set. Okay. Nope. Nope. Doesn't work. Turn the list to a set. Wait, what do you mean? Turn the list to the set. Can't I do this? Number of occurrences of a value. What the hell am I doing wrong? 1, 2, 3, 4, 5, 6. Putting in the dictionary the value that I count in the dice. So that seemed to work just now. But I need to look. It printed 2 times, but what happened with the 3rd time? 3, 3, 6, 5, 4. It returned the wrong thing. But where is that print? I should see 3 prints. Why do I see just 2 of them? Something is a bit fishy here. I have 3 tests. Oh, I don't see the 3rd one because it stopped here. That returned the wrong thing. Do I count correctly? 1, 0. That's not right. 1 to 0. I should not be doing this put unless if there is something inside. If self dot dice, okay, dot count of value is equal more than 0. Any other suggestion is welcome. I'm not following the, yeah, good. Okay, with this, of course, and a good, well-deserved tab. Run. Still no. Self.dice.count of value more than 0, then I have to put it. And I have this. That shouldn't really matter. Dict items. If value is more than 2, then why did I return the wrong thing? I don't see this yet. This one failed. Let's put it in front of us to have it clear here. The old value worked correctly, but this one didn't. This produced 3, 2. Where the heck are the 6? Oh, can't believe this. I can't believe this. My daughter is going to laugh at me. Dad, don't you know that we always do it inclusive? I mean, +1, basically. Damn it. The range is inclusive here, exclusive here. Bad, Victor. 10 push-ups. So we have a 4. And then, does it matter if I do the if here, or I'm just putting it? No, doesn't matter. Perfect. Okay, so I'm okay with zeros in there. They don't harm anyone. Good. Now, all of this, of course, can be created as a comprehension. We comprehended the list before. Now we're going to comprehend a map, a dictionary. How does that work? Instead of all this, I'm going to say dict equals, and I'm going to say comprehend the value, and the count of items for value in this range. Only 2 minutes forth. Done. There. What am I doing wrong? Value and self dice of that value for value in range. What am I doing? What am I doing wrong here? Is this the correct syntax? Value. Aha, excellent. Thank you. Thank you. Thank you. Crowdsourcing. Run. That should do the same thing. Perfect. Good. Now, how the hell do I do this now? How the hell do I check this? Well, let's try again, our luck. This dictionary, can't I just filter? Can I iterate through a dictionary? Of course I can. I do it here. Okay. Okay, let's see. Values in pairs. Actually, the first refactor would be to understand that I can do this in one go. I don't need to count the pairs. I could first say, let's say, repeating dice equals empty array. And then instead of doing plus plus, I could do append of the value that I just found, k. This dice repeats this amount of time. Then, if the pairs, and then I don't need to iterate again through it. I have all the values which repeat two or more times. That's a trap here. So what I can do is to directly say sum of the dict.value.keys, all right? And then multiply by 2, because those were just the values that repeat, not the one. I broke it. Let's see, repeating, oh, I should be iterating through these, of course. Run. Not yet. If the value is more than 0, oh, I don't need to use n pairs anymore. I need to just say this. Length of this. If it's not exactly 2, then return. Green. Now, can I do this a bit better? Let's see, repeating that. I can compute this in one go, can I? I can say equals to comprehend this list if this, and basically getting out of this just the k. Okay, for kv in dictionary if the value is more than equal to. Okay, that's fun. Green. Thing is bugging me. Good. So length repeat. If repeating dice equals to, good. It's a spammer, by the way. For number in set of array, what is this? For number in set of array, occurrences of number equals array.count. But why do you make it a set? To avoid iterating for no reason on values that are never there. That's smart. Self of dice. I like it. Same thing. So I won't go through all the values, but only those that really are in that collection. Like it. So for value in those that appear unique, I'm gonna evaluate how many times they occur. Fair point. And then I won't have any zeros, but if I do this, do I? I won't have any zeros in the dictionary anymore. Repeating dice equals, and then if the repeating dice is equal to 2, then return. Wait, I can do this fun, and I can do this in a better way. Wait a second. I can say return this if. Now you might disagree with what's going to happen. Return this. I believe I need some parentheses. I am not happy with what I'm seeing here. Parentheses. This is equivalent of the ternary operator from other languages, your beloved question mark to colon, else 0. So basically this if now it becomes an expression, not a statement. I'm doing a sum of these times 2, if and only if the length is equal to 2. Let's rename this repeating. All right. If repeating are at least 2 of them, then I return. This can be a bit cryptic. I'm not big fan of this really. But it's Pythonic, one expression. 3 of a kind. Do I smell copy paste? Am I really gonna copy paste in front of all of you? Nah. This is in particular is pretty creepy. So let's make a method out of this. Let's say like frequencies. Frequency. Ooh, good name. Frequencies. That's actually good. Well, although I would repeat. Dictionary frequencies. And how many times do I use this? Once. Perfect. I can align this here. Beautiful. Beautiful. Absolutely beautiful. And now copy paste. So the condition is 3 of a kind. I need to find one of them, which is at least 3. And then that which is repeating, I need to take the biggest of them. Pay attention, there is a trap here. Oh no, 3 of a kind. No, there can only be one element that appears 3 times. There won't be a room for another one. So technically, that repeating times 3 if this is not empty. And as far as I know, you can just test for emptiness like this. I might be completely wrong, but let's check. 3 is of a kind. Yes, apparently I did that wrong. This is true-ish. The collection, a non-empty collection evaluates to... Yeah, I get the point. Cool, good stuff. Let's see. 4 of a kind. Copy paste. Copy paste. And then I should have 4 and 4. Don't you love when you reuse? Okay. Small straight. What the heck? When placed on a small straight, if the dice is 1, 2, 3, 4, 5, exactly these 5. I sort the dice on the self. Can I sort them? Of course I can. So sorted should be exactly this thing. Should be exactly 1, 2, 3, 4, 5. And if that's the case, I return 15. Perfect. There's 0. This reads like freaking English. Thank you, Python. Large straight, same stuff. I did not test this. Where are you? Small straight failed, no. 1, 2, 3, 4, 5 returns 15 if. 1, 2, 3, 4, 5. What am I doing wrong? Small straight. And it failed at this first assertion. 1, 2, 3, 4, 5. Self.dice.sort. What am I doing wrong, guys? Really cool. 1, 2, 3, 4, 5. Beats me. To me, it reads pretty English here. It reads pretty correct. I don't need to do anything else. Just 2 equals 1, 2, 3, 4, 5, 5 equals 0. Strange. Which leads to the following question. If I compare 2 arrays like this, do I see, let's do a little check. If I do this equal to this, will this work? Apparently it does. But it could be, that I'm misusing sort. Let's see, sort, will it sort in place? What does this give me back? None. Whoops. Whoops. In ascending order and return none. Shit. I'm comparing none. So I would love to see like sorted, but I don't think there is such. So I will have to, ouch, I'm gonna change my state. Come on, there should be a way to do this. Come on, I can't believe this. Is there any way to produce the sorted version of an array without sorting it in place? I was looking for the same thing, but apparently we're out of luck. There is no such sorted. I would expect this, but no. Does this already work? Or okay, thank you. Built-in sorted. Yeah, I'm gonna test it. All straight. Didn't work. List had no attribute sorted. What am I doing wrong? Sorted exists, but why don't I see this here? It's an array. What am I doing wrong? Sorted of. Backwards. Thank you, of course. Yay. And small straight. Yes, green. Good. Thank you, AI. Thank you, people. More thank you, people. A large straight. Good. This thing here. Paste 2, 3, 4, 5. Yeah, it's easy, boring. Good stuff. Good stuff. Good stuff. Full house. If the dice are 2 of a kind and 3 of a kind, woohoo! Wait a second. I can use the other 2 because 3 of a kind returns the. Wait a second. but they should both return non-zero. That's tricky. So let's say 3 equals 3 self dot 3s and 2s, not 2s, pair equals, I'm going to use the other functions we've constructed, 1 pair, and then I'm going to return, actually I need to return the sum of all the values, right? 6. So it's easy, I can just sum of the self dot dice, if, only and only if, both of them are non-zero. This is non-zero. Else, 0. I'm afraid. No. Why not? Why not? 6, 2, 3, 4, 5, large straight. If 3 is not 0 and 1 pair is not 0. Because the 3's pick. The test that failed looks something like 2, 2, 2, like this. And both 3's and 2's, they select these as being the correct. So no, it doesn't work. It doesn't work. It says, so I have a pair and I have a 3's. No, actually you don't. It's not a full. No. Nice try, but I can't reuse over here. So let's see, how else? Well, I need to do the same kung fu with the frequencies, probably. Let's give it a shot. Repeating equals, not repeating, I don't need to select directly. I need to do this twice, probably. All right. Let's call it F for some reason, or frequency. And then I'm going to say, how do I do this? No, let's say 3's, and they should be exactly equal to 3. That works. And 2's, because there is no pair. There is no such, let's call it trios and pairs. Trio and pair, exactly this. I select the value, okay. And if it's easier than this, isn't it? I just have to find that in the value of these frequencies, I have a 3 and a 2. That's fun. Let's try. So technically, the frequency dot values sorted are equal to 2 and 3. If you have one die appearing 3 times and another one appearing 2 times, the game is over. You win. And if you win, you get the sum of all the dice. Or else, 0. Isn't that cute? And if that works, allows me to destroy the. Let's see. Thank you. Full house. But I got wrong the large street because it had to return 20. Guys, don't do development the way I do it here. Please. Be more serious than I am over here. I'm just that it's late. I'm just trying to have some fun, to play with Python, and to justify the myth that Python one-liner. There is a famous book in Python, which is something like writing Python in one-liner. And the true Python developers write code in one line. That's a myth. Okay, yes, Python can do this, unlike many other languages, but don't do it. I'm not sure if I can phrase this better a bit. If I have an element, any element, I multiply it by 4. Otherwise, I return 0. Now I'm getting in this game, you see? I'm trying to see, can I compact this to a single line? I'm using repeating twice, which is not good. So, there is a way I could try. What happens if I return the repeating of, this is an array, right? Of 0. That could be none. What happens if I multiply this by 4? Or else 0? Am I reading the right operator? I'm not entirely 100% sure. What is the default for coalescing? Let's first see what it returns now. Least index, I can do this. I can't. I would love to take the element on the first position. I have a Python list. I wish to take the element of the first position, if any, or else get a none. How can I do this? Let's see. Well, anyway, my list of 0 if... no, I need to repeat that. Shorter. Next, wow. Brother, ooh. But for the sake of argument, let's try. Repeating, iterator, none, and then I multiply this by 4. What the hell do I get if I multiply by 4 and none? I can't multiply it. But I could say 0 here. Yay! One liner! Ladies and gentlemen, the prize for the most geek. I'm not a fan of this. Just saying. Why are you so long? Why are you so long? One pair. Wow, that's with frequencies is a child play, right? But then let's do this because it could be fun. There could be 2 pairs. There could be 2 possibilities. For example, 3, 3, 4, 4. I need to pick the biggest one. So I'm gonna say, yeah, more than 2. But then I'm gonna take the maximum of these. Yes, and then I'm just gonna say, but what happens if max gets an empty value? That's gonna return what? A none? I'm gonna be dumb here. I'm gonna play dumb for a moment. Thanks to tests, I can try whatever. Repeating times 2. Run. Okay. For no pair, look, the test that I wrote so carefully, now it pays off, says, hey, there is nothing there, and I'm trying to max, which is an empty sequence. So what? Why can't you just... I know, I could say concat with 0. How do I concat an element to a list? Nah. I can't do this, can I? So stupid. Max fails me over here. If I have an empty list, I would run to concatenate a 0. I'm playing dumb over here. I'm playing... I can't resist. One liner to concatenate, to add an element to a list. It will say append, but nah. Expression. There you go. Now we're talking. I'm gonna guys, I'm ashamed of what I'm doing over here. I'm gonna end this madness in a couple of moments. But it's green, just appreciate. Repeating times 2, done. Yay. One liner. Don't do this at home, please. I'm gonna close this exercise, right? But not before I do this. What is this?
Ooh, what does this button do? Please, please.
Default argument, room for misunderstanding, and oh, I never knew that I have to pass 5 arguments. I believed 1 is enough. You don't want these discussions, so every time you can, and if you're not building some library used in many places, try to get more precise with your parameters. Then this, what the heck is this? 5 is the zeros, and then come on, you can do better than this. Dice equal, of course. D1, D2, D3, D4. Some would say, why don't you take an array vector over here? Why don't you take an array so that you don't have to take 4 arguments? Because 5, because I want for people for the compiler to complain to the linter, hey, you're missing an argument, or you're passing too many. And I will put inside for my convenience into an array. That's the surface of my class is expressive, asking 5 things. Inside, I manipulate it as a list because I choose to. Yatzi, what the heck is this? If all the dice have the same number, oh, that will be beautiful. That will be beautiful. Then you score 50 points. Oh my God, that's the bigger. Okay, in one go. Now I'm heated up. Return 50 if, I got this. If length of the set of the self.dice equals to 1. Else, 0. Okay, ladies and gentlemen. Fun. Really fun. In a weird way, but fun. So let's spend 10 minutes on the Zen of Python to really justify, talk about all these. all right, and try to relate with what we just did. It's a kind of a, I don't know, follow-up, like a conclusion, let's say. Beautiful is better than ugly. I believe we cannot disagree with this. Yeah, correct, Alex. Good one. Beautiful is better than ugly, which really means I have a slide for this. Why am I showing the raw version? Just a second. Clean code, thank you. And we have at the end here the Zen of, there we go. Beautiful is better than ugly, which means that technically that our brain loves aesthetics and symmetry. If you can, align the consistency and symmetry of code, it will, for example, test ones. Why the heck test ones? Why are you playing with me? Ones, twos. Be consistent in what you do and try to follow a certain aesthetics, right? A healthy dose of obsessive compulsive disorder is always welcome. Explicit is better than implicit. Of course. But if you ask it, you put it like that, you don't want to make some weird assumptions. This code that I wrote over here with one-liners at the end, this is not good code in this sense. This is not explicit. This, okay, I understand, but this is not explicit. I want those versions before they were more readable, right? Introduce a method that would have a name, put clean variable names. Simple is better than complex. So basically strive to find a simple solution to any problem you are facing. So try not to take pride in how complex code you can write. Try not to take pride in such code, but instead aim for code that everyone in the team can understand. Complex is better than complicated. So some problems are complex by nature. You cannot run that. You don't want to go for an overly simplistic solution to the business problem, but you do want to stay away from over-engineering, of course. Flat is better than nested, of course. In the original solution that I spared you from, there was some method that was like 3 or 4 depth level, tab levels deep. And we ourselves wrote code which was very, very deep. Now all the code in every method is completely flat. By the way, if there is any non-Python developer looking at this, there are functional programming alternatives to writing this beauty without going into for loops and changing collections or adding to numbers. Sparse is better than dense. Explain the rules, explain the train of thoughts with variables and methods. Don't write everything in one line, despite the Python book. Good. Readability counts. But you do want to use comprehensions, okay? Yeah. If you're writing fresh code in Python, it's a pity not to use them. This is absolutely English code, right? So sum of die for every die instead of dice, if the die equals to 1, that's it. It's English, right? Optimize code for navigability. This is one dear topic of mine. When we write code, you always think of the time you're going to spend browsing it, because it appears that most of our time is spent running through code, finding our way, looking for that bug or that performance issue or that, just getting to know the code, browsing it, right? A smaller percentage is spent deeply reading it in the slow thinking brain mode, right? Just imagine you found the bug in 20 lines of code, you have to really understand what causes it, right? In that line, or you have some performance tuning to do, or some bigger redesign. That's where you go deeper understanding of the code. And a very minority of the code, very small minority, is dedicated to writing it. So it's clearly that you want to optimize the code for browsability. Can you say this? Browsability. So spend more time to, of course, make yourself a better, easier life tomorrow. Now, in Python, there's something special happening. Python is very often used in experiments, data science, engineering, business intelligence, in which we're just playing with stuff, playing with ideas. Okay, but the moment that idea becomes a product, be aware and pull the brake and optimize the code for further maintainability. Okay, so Python is a wonderful language to play with ideas, but at some point, others are going to read it. You're going to read it 6 months later. You want to have mercy on yourself. Special cases aren't special enough to break the rules. How many times have we thought that, hey, we are running into an absolutely interesting, incredible problem, right? Then, looking around in other companies, you realize that hundreds of companies have done the same thing themselves. You just look harder. Your case isn't as special as you hope. It's also a matter of how much experience you have. At the beginning of your career, you are, wow, I need to do frequency dictionaries. How smart am I? My daughter in 5th grade does this. It matters of your exposure. Right? Although practicality beats purity, this is again very deep. Clean code is no good if it's buggy or slow. So I have so many examples to give, but time is running out. So imagine cleaning up the code by repeating a database query in a loop. This is absolutely stupid, right? You don't want to do performance mistakes just for the sake of clean code. So clean code goes, and expressive code goes just as far as until it gets slower or buggy, right? Errors should never pass silently. Basically, care for the errors, okay? And compare them versus the client. What should I do? Should I do anything? Should I report? To who should I report? Sometimes we report the errors to the wrong parties, to the wrong stakeholders, right? Unless explicitly silenced the exceptions. Some occur regularly on purpose, so you just want to ignore. In the face of ambiguity, refuse the temptation to guess. Oh my God, how deep this goes. You are faced with a requirement, you don't understand how you should approach it, and you are taking assumptions. Don't. If you can, try to ask questions. Go ask the project owner. Blame the code you saw. Ask the elder in the project why the code looks the way it does. There should be one and only one obvious way to do it. This is about maintaining code consistency. Code in a project should feel like it was written by a single guy, like it was written by one developer. Okay, so the technical lead's job is to enforce this, maintain consistency. You do not have comprehensions over there, traditional for loops over there, mixing up all the things together. Try to adopt a single. Although that way of doing it might not be obvious at first, unless you're Dutch. Why? This makes no sense. The inventor of Python is Dutch. So basically, what they want to tell you here is to understand and follow the philosophy of the language, even though that might not be obvious if you come from another language. Comprehensions are something particularly interesting in Python. Now it's better than never. Don't defer cleaning up for later. Although never is often better than right now. Don't rush to quick fix something until you fully understand what the problem was. If the implementation is hard to explain, it's a bad idea. Classic one. If you can't articulate what the hell you're trying to do, don't do it. It's a terrible idea. Yeah? Try to pair program, to peer review your stuff. If the implementation is easy to explain, if you can articulate it, it may be a good idea. So technically, warning you that the first solution to any non-trivial problem is usually wrong. Be ready to revert to safety and take its small steps again after you discover what you're supposed to be doing. Right? And then namespaces. I've used classes here. Many of you Python developers are probably, oh, classes. No, we don't do that here. I know. That's exactly my point here, to put you out a bit of the habit. Most Python code I saw is just functions thrown all over the place. But now if you have many functions operating on the same piece of data, that provides a clear advantage that you don't need to pass all the arguments every time. You just take them from the class. Right? Classes are invented when you have more complexity to manage, technically speaking. Right? The Zen of Python. Right? Lessons from Python that you can take basically in every language you want. Right? And I hope I covered these ideas here. I forgot to introduce myself. Oh my God, this is embarrassing. So it's stupid to do it at the end, but better later than never. My name was Victor Renta, coding in Java for 18 years in many other languages. I'm doing consultancy and training for many companies all over the world, including states recently. Architecture, refactoring, unit testing. This is what I mostly love doing, but also today Kafka Streams, Spring Framework, GPA, performance tuning in Java. They are all on my catalog over there. I did a lot of talks at conferences that you can find on YouTube recorded. So good material, very educational, very intense, straight copy pasted from my training material. Right? When I find myself repeating the same ideas 4 or 5 times in different consecutive trainings, I usually extract the talk, put it on the YouTube, and then I just point to my trainees, watch that, and then we'll discuss your questions. And what we just happened today was a webinar for my beloved community, to which I promise to share more in the future. I'm also on these social media, but not very active. As active as I can be to keep my focus. Guys, I think I'm done. It's late for my side, so thank you very much for being here. It was. I hope you enjoyed it. I'm gonna push the final code here on the Git. I'm gonna put all the Git as usual on our community, and we will meet each other hopefully next month. If not, maybe the month after for sure. Good. So end to geek. I'm sorry. Good. And with that, I will finish the day. Thank you very much, guys. See you next time. Bye. Getting out in 3 and 2 and 1 and 0 and -1, over and out. Bye. I should stay more to talk with you, but reach me. Yeah, my Python trainings. As I learn more, I might. I'm being contacted more and more by BI, by machine learning related teams that are playing with it, GPTs. Their code starts to get out of hand, and they, hey, let's clean it. Who to call? So I'm going to learn more about this world, and maybe even some frameworks soon, probably. Good. Till the next time. Goodbye. And the one here, end stream. And close this.